Hi, folks. I hope you can hear me.
Perfect.
Great. Awesome. Thanks, Kotlin London, for this opportunity and Enzo for this great introduction. And this has been a great platform. And today we'll be talking about functional programming. I'm live from India, and it's 10:30 p.m. here. So it's an awesome, great time to give a tech talk. And it has been an awesome day. And I hope we'll have a great hour together. And by the way, I'm Gopal, and this is my Twitter handle, Gopal Akshintala. I work for Microsoft, and this is where I there's my blog URL, by the way, overfullstack.github.io, where I blog about various things like functional programming and other things. And let's get to our talk, and let's start our talk with a small quote. So this is something I keep hearing a lot from the managers, especially they say that FP is cool because it's complex enough to make devs feel like they're doing something smart. I don't know. I at least see that kind of hesitation whenever someone wants to introduce FP, or if you want to tread towards FP, because FP somehow isn't really into the masses, and people still see that as complex. And today we're gonna bust that myth and want to prove that FP is not complex. Instead, it fights complexity. By the way, this is not my manager. This is some manager. So today we're gonna see a story, a true story, and the things that happened actually in a company, and then how we were able to push functional programming after a lot of discussion and all the design decisions and all the discussion that we made. I'm gonna put this in this 1 hour little talk. So without further ado, let's get on to it. By the way, in this talk, this has something for everybody based on where you are in the functional programming journey. Like I'll start with a very basic imperative versus declarative coding, and then we'll slowly ramp up towards monads, and then we'll end up with something more than basic or advanced stuff called like functional lifting, etc. I'm gonna present you with a case study wherein we're going to solve a certain design problem using functional programming techniques. So let's get on to it. But before that, let's start with something very serious, like all those serious dev holy wars that keep happening in our day-to-day, teams and day-to-day life. So the first one on my list is ideal light versus dark theme. You know, this might sound silly, but this is a really big war. People just keep looking at each other. At least people hate people who use light themes. They see they're kind of old and other things. Like I used to love light themes, but then not until I bought my 32-inch monitor, I really understood the value of dark themes for my eyes. So they're pretty awesome. But then still, I see people kind of have this for at least when it comes to themes, etc. And the second one is this uh, also in the sense this Eclipse versus IntelliJ. What keeps happening in our floor, like within our team, people kind of use mixed IDs, and they think the other ID is kind of boring. But then why am I talking about all this? What about this war? Have you ever had this war in your team wherein people say, "Hey, oops is better than FP," or "FP is the one"? I kept hearing these wars. I kept hearing these discussions when I was a junior developer, and that enthused me towards FP more and more. And I was pretty, I was like very enthusiastic to understand what's the difference between both. Like I have gone through a lot of books and all those case studies, etc. And then in the end, to realize that there aren't two exclusive things, and I can never imagine something that is exclusively done with FP or exclusively done with object oriented programming. And there are no concepts as such which are exclusive to one paradigm, and they both should be used together most of the time, and I can't imagine where they can't be used together. So if you see oops can be put into all the solid principles that Uncle Bob has uh, uh, formalized, and FP can be put into these principles. FP kind of the major popular principles in FP are immutability, referential transparency, and side effects at boundaries, etc., etc. And as you can see, none of them contradict with any of the principles in OOPS, and they both should be used together. And even in this talk, we're going to address a popular OOP paradigm with functional programming functional programming principles, so which is going to turn exciting, and we're going to prove that there is no exclusivity between these two paradigms. So, but there is one thing that that still is fought, especially I see somebody like this guy in the middle as a Kotlin developer. So, who is a Kotlin developer? A Java developer who transitions to Kotlin. So I call him a Kotlin developer because he's kind of confused with all the rich functional programming tool set that Kotlin provides, and he might not be having that in Java, at least till Java 8. And even after Java 8 has come, it's kind of didn't come into popularity. Even today, I see a lot of people in production use Java 8, but still fail to use lambdas and all its functional rich library things. So the thing is, now that I have started learning Kotlin, and Kotlin really have inbuilt a lot of functional rich set. So a developer who has just entered might be really thinking, what is this imperative versus declarative programming? Let's see what's the difference between those. So I would say I would start with an example, thinking of imperative programming like this, wherein it's like you have a lot of puzzle pieces together, and then you have an instruction set to how to fit them, like do this first, do this next, and all that stuff. And then together you give it to the computer separately. So for a computer, it doesn't matter. It can kind of look at the instruction set, look at the puzzle pieces, and fit them together, run the code, like put a bytecode and run it. But for a developer who is actually reading your code, it kind of feels like he's reading a script or something. So let's see the difference through an example. So let's do a team building activity. We are all been isolated recently because of this COVID. So a little team building activity can help. So the activity is, let's try to concatenate all the last names in a team with a delimiter. This is the delimiter I'm using. So the string I'm looking for is something like this, which is the last line of it. So let's say a junior developer who is kind of used to developing in Java starts with this function, and then tries to achieve this, and then submits it to code review. Okay, a senior guy looks at it and says, "Hey man, what about all the corner cases? Did you even think about all the corner cases?" So what are the corner cases? When we are at least dealing with strings or anything, at least in Java, you got to be very careful with nulls. At least in Kotlin, we are really lucky that we got nullable types, which declaratively say that this particular thing can be null. And then there's white spaces there, etc., etc. And by the way, don't bother about the code. It's I'll be sharing the slide deck as well as the code links, etc. And you should be able to understand. As of now, just trying to understand the concept, and then if you have any questions, we can still deal with that in the end of the talk. So he's trying to extract last names based on white space, etc. And then, of course, he has a lot of corner cases to deal with. And then he comes with a patch. So because he is doing that in imperative programming, all he can do is patch his code and add more lines of code, which kind of really dissolve the meaning and core logic of the code. And he again, what he does is he now adds a null check and does all this, etc., etc., blah blah blah. But the output uh, looks this way, wherein he has an extra delimiter in the end. So again, the senior developer screams, did you even test the code? Where are the test cases? So again, he has to go back, think, and then comes up with this bigger patch, wherein he had to have a flag for whether it's a first or the last, etc., etc. And then looking at this code, I remember this agile horse. Like this is like a patched art form. Like any other art form, as you keep patching things, you lose the actual meaning of what it tries to convey. And this code is kind of lost in conveying its meaning. And this is a very simple example. Imagine the same thing we keep doing day to day in production code, and we have hundreds and hundreds of lines of code which kind of just read like a script, which don't speak for themselves, but you have to, as a developer, put debug points or spend really some good time understanding how the code flow is going on, how the state is flowing, etc. So imagine this guy is born in a parallel universe like a declarative programmer, and given the same requirements, he would start with his code this way. So this code is analogous to this. So this is how he would do with declarative programming using sequence. So sequence is pretty popular in Kotlin. I'm not going to go into details of map, flat map, etc. I request you to go into the documentation and look for it. But we're gonna slightly touch upon what a map and platform does, but then not in detail. And then this is how we can declaratively write his code just having in two different lines. That's it. And then once he understands about those corner cases, he would extend his code, not patch, but extend his code by adding few more conditions. So this is like an SQL or any other declarative language wherein his state flows in a single direction without any confusion. Just like you keep looking, and such a compression ratio this has got, and this code fluently speaks of what he's doing. And then you could see how this code is being turned into this step by step. This is I don't want to go into details. I want to focus more on the advanced part towards the end within the time. So you could see that each and every part of the code is now made very concise and put into the simple lines wherein you can declaratively call them. So this is imperative code. We have seen it. I would say this is declarative code. It's like the shapes are already made up, and then you're giving it to the computer, not with an instruction set. So for a programmer who is reading your code, this matters a lot because it already has a shape on the canvas of your IDE, so that you doesn't have to put your mind in trying to build a shape in your own head. That's the beauty of declarative coding. But is it just a syntactic sugar? Whatever we saw, is it just a change of syntax or is there move to it? So we all know Java is like the lion king of languages. There is no debate about it. It's being the predominant language, and it is kind of invented when I started going to school, elementary school, and even today people use it in production, and it's no joke. But then Kotlin just recently got into that space, JVM space, and quickly gaining popularity, but still the adaptability is less. But then now Kotlin has such a rich functional programming a tool set, and then Java is following up with Kotlin. So why is this? Why is this now that modern languages are running towards adding more and more functional set programming tool set? So let's try to dig into see if this is just about style or not. So let's try to give a wrinkle to a problem and try to do everything in parallel. So all the concatenation, the requirement has changed uh, to get it done in parallel. So this code, imagine how you can get it done in parallel. So there are multiple ways like using fork join pools, using coroutines, etc. I have an implementation which I'm not going to show in this talk because of limited time, but I'm going to share code links where this code is turned into parallel actually. And then you can imagine how dreadful that might look like. It already has lost its meaning. It's already verbose, and making it into parallel kind of you totally lose what is going on. And it's so difficult as well to push such code into production because there are a lot of cases and scenarios that you have to keep in mind. But the actual problem here is not the syntax, not just the imperative syntax, but the mixing of how to do's and what to do's. So the how to do's in here is looping through the list, aggregating the results, and what to do's are validating the names and extracting the last name. Thing is, the problem is in our imperative style, we kind of mixed both these concerns, and that has led to having more and more verbose code now that one of or two of our concerns have changed. Like looping, if I change the loop to parallel, looping through parallel, a lot of things has to change. I probably have to rewrite it. We kind of face such scenarios in real world as well, and we kind of don't understand what the exact problem is. The problem is this: now in the serial to parallel, all I have to do is just changing this to a parallel string or something synonymous. So the reason why this is so simple is of the core context principle, and this applies to any paradigm, not just functional programming. You always got the right to an abstraction. So all our previous code is working on abstraction called sequence, and all I got to do is change that to a parallel stream or something else, so that entire code runs in parallel without actually changing any other line of code. So that's the beauty of the core context philosophy, and always you got to stick with the context rather than trying to write imperative or sequential code. So we are almost kind of halfway, and kind of I got a bang for you guys. So sequence is a monad. So I hope some of you might have heard about monad. Some of you kind of felt that's not my thing. Like we don't really use monads in real life. But then, what is a monad? It's really as dreadful as it is told to be. Like this was my initial days while I was trying to understand and read about monads or functors, monads, applicatives, etc. Going through those terminology like monads are the monoids in the category of endofunctors, etc., etc. That almost sounded like a Harry Potter spell. So monads, there's also a popular joke about this. Like once you understand monads, you kind of lose the ability to explain them to others, which of course I'll be doing tonight or today to the in the evening, which is kind of ironical. But then today there are different things like functors, monads, applicatives, and they're all different. But today, for the sake of a sanity, I'm just gonna call all of them monads. If you want to really know about this, there's a great article by this guy in Kotlin, which is a translated version from Haskell, wherein he explains what are the difference between all those three. But for now, let's just call them monads. So I'm gonna use this fantastic library called Arrow, and there's a fantastic sum type which comes from Arrow. It's called either monad. I'm gonna start with that. And coincidentally, Arrow just released 11.0 version a few minutes ago before the talk. So, and kudos to all the hard work they put into, and that's an awesome library that every Kotlin developer should go and explore. So the either monad we're going to use today has two states. So basically, what is an either monad? Basically, what is a monad? Monad is just a design pattern of doing things in a certain way. So today we're not going to jump into how to write a monad, but just want to see the application of monad and where we can make use of monad in our enterprise software or day-to-day software. So, but a brief introduction or a crash course on either monad. It's a monad wherein it has two states. Imagine this like two boxes, wherein a box. So you can call them as left and right state, by the way, and you can represent these states in any way. But in our talk, will be and even predominantly left is generally used for representing errors and right is used for representing valid values. So similarly, we'll be using the same today. So imagine a particular object is in the right state. So it is being processed. Okay, we'll go into more in the subsequent slides. So I'll start with a very simple what is a map. So imagine in a normal scenario wherein you have a function and you got a value and you got to do some function, some transformation of that value and then return it. So this is how you normally do that. But if the function, but if the value is present in the monad box that we have seen before, this is what happens. You actually pass the function to it through map or flat map that we have seen before, and then the function is applied on that particular value, and then the result is put in the box, monad box again. And so this is how you normally achieve that with either monad. So you kind of instantiate the moment you do either dot right of two, you're kind of putting that uh, 2 inside the right state of the monad, which is the right box, a blue box. And then the moment you pass a +3 function to it, it is kind of applied on it, and then you get a result back. Fold is like a terminal operator. Again, I request you to go into the documentation and to read about all these operators in depth if you're not familiar with them. And similar analogy applies with sequence as well. So let's say you have a sequence of various things, various integers, and you want to apply the same function on one of each of them. And all you got to do is just pass this value through map, and you would get the result of 579. So we are doing this in a declarative way, and this is again map. This is called functor, but like I said, I'm just going to refer to monad when I just talk about map. And the monad is something which also has a flat map, but there's a deeper meaning to that. Like I said, please go and refer the article. So what happens when there is no value inside your monad? In the sense when the monad is in left state, when either is in left state, so nothing happens, nothing really blows up, and the function you passed would just be ignored. It wouldn't be applied, and the left state continues in the composition. Like if you see, you have passed a +3, And then if it's in the left state, nothing happens. It still would remain the same in the left state. This +3 won't really affect it. So this kind of behavior can be used wherever we want to chain functions. So normally, if I don't have a monad, I would do something like this. If I have to pass result of one function into another, just like in maths, you do f of g of h of x. But if you have the same value inside a monad, you can chain the functions one after the other, all the transformations that you want to apply, and then get the result. So this is more clear and more extendable per se. Like I can add more functions in between without actually twiddling with the code. So this is how you can imagine this kind of composition, wherein you have a box, you have a value in it, and you're passing that value from one function to another. And what happens if the box turns to left state in the middle, nothing really happens. Subsequent functions wouldn't be applied; they would be ignored. So we'll be using this particular property in our in solving our design problem that we're going to see now. So ultimate question. So we just had a crash course on monad called either, and there are so many other monads that you can go and explore, and they're so interesting. And each and every monad has a purpose. But does are monads really used in enterprise software? Are they just like theory? So I'm going to come back to our experience in our team. So we really had a cult following for monads, and because we had to do a lot of brainstorming and deciding whether to really embed monads into our code, because there was very little functional programming expertise in our uh, team that time. And then we were kind of not sure whether if that makes our code more complex and less readable. And then we had a lot of discussions on that, and finally came up with a library called Vader. And I'm going to show a glimpse of this library without kind of showing you the production code, the parts of it. It's of course a smaller library, but then it adds up a lot of value in trying to solve the problem. But what exactly is the problem? So let me just talk about the requirements of our problem so that we'll jump into solution. So all we're doing is we are developing a parallel REST APIs. So we are a payments industry, and we have like parallel services like payments, refunds, authorization, etc. And all of them are just simple JSON requests, like their request body would be JSON. But the funny part is we have a lot of JSON structure to share between our various services. So what I mean is, let's say you see a payment method here. The same payment method with the same structure will be part of another service with the same request body. So this kind of made our problem tricky, because we had to validate this request, and we'll see what the problem requirements are. So we had like all we got to do for us a simple data like amount is do a simple data validation, like whether this is not $1 billion or not negative. And then for something like this, to validate something like an account ID, we got to do a DB call, which kind of is error prone, throws exceptions, etc. And we got, as I mentioned, a payment method. Payment method is a shared, I call it a shared child object, so that this particular, as the same structure is used across the same different services. So the part is, I don't want to rewrite the same validations across all the services. We're supposed to share those validations. But then I'm going to show you how, if I share it using imperative style, how difficult it becomes. So for dealing with this, by the way, the another tricky part is this is a batch request, wherein the same we'll get a list of these JSON objects. So we got to deal with some tricky things like partial failures, which I'm going to discuss going forward. So we had to design something called a batch validation framework to validate those batch requests across shared services, across parallel services, you can call it. So just for the sake of this talk, again, like because I can't show the production code, I'm just gonna replace this particular guy with an egg. So I'm gonna call it, we are validating eggs. So imagine a particular service is getting a list of eggs, which we're gonna validate and put a bad eggs and good eggs separately. So that's kind of business problem for the day. So let's get into the requirements briefly. So I got to do So the requirements are I should be as a developer should be able to configure the order of validations. So what I mean is, so normally in validations, well, we have one route where we want to fail fast. So when I say fail fast, we want to do the cheaper validations first. Let us say if the amount itself is invalid, I really don't want to do a DB call and then validate account ID as well. And I don't want to really validate any of the validations of my children. So that way I should be able to configure which validations comes first and which validations come next, and should be able to shuffle those as well. And cross-share common and nested validations. So like I said, this payment method should be able, I should be able to share them for other services as well without rewriting in the same, and they should run in the same context. I'm going to get into that soon so that you'll get better understanding of what I mean. And we want to support both fail fast and error accumulation on each sub request. So we got two routes to a service actually. That's more complicated, but just for the sake of this talk, understand that one route we had to do a fail fast, and the other route where it's actually shown on UI. I have got to do error accumulation, wherein I got to really run all my validations and check what are all the errors and then return back all the errors. But then now that the two different things, if I write them and two different code bases, in the sense two as a two different classes, I had to repeat everything if I had to do it. So I'll show how the code ends up looking like. And partial failures is something wherein if I have a batch request, I want to really capture few of those which are failures and want to send them down to various layers. So something like this. Imagine my validation layer is failing, let us say two of them. But then the problem in the batch services, I am not supposed to send these error responses right away. I got to really hold on to them until I kind of cross all the layers, and only towards the end I can send an aggregated response. So, but then how do I hold on to them and then not let them get processed in the subsequent layers, which is tricky. I can't store them in a temporary place because I'm crossing boundaries of layers. So that's wherein another requirement which we're gonna cater. So with all these requirements, we also got some meta requirements, like we want to accommodate a century of validations. So imagine if it's just few validations, you can write them in any way. We got some 100 validations across multiple services, which is kind of a tricky thing because you can't manage validations if you have so many validations if you just write them with a simple if else condition. And unit testability is very important for us because the validation, even simple validation, have a lot of corner cases, and we shouldn't compromise on the performance. That's ultimate. So, like everything in the world, real world, requirements are never constant. They're agile in the sense. Let me explain what I mean by agile requirements. So, on the day one, we just got one egg and one validation. Life is very simple. All I got to do is pass that egg into the one function which validates, which kind of tells me whether it's valid or invalid. Fine, cool. So kind of like the requirements change. We had to now got a batch request, but then we still got one validation. It's still okay. I just have to pass the loop all the eggs and pass them into the validation, and then I get back a list of results. It's not that difficult. But the moment I have many eggs and many validation, life really gets complicated. So imagine I kind of do the same in an imperative style. My code ends up looking like this. So this is a dummy code again, and this must be very familiar to a lot of you guys because we see this in our production a lot, wherein we kind of have this chain of if else conditions, try catches. They even sometimes overflow on this from the screen like an inverted pyramid. So I'm just going to briefly explain what is going on here. It's very simple. Uh, so I have got a list of eggs which I have to validate, and I'm going to return a map which has the egg ID as well as whether a particular egg is valid or does it have a validation failure. Like I am not interested on bad eggs. What I'm interested on is why the eggs are bad. So I have various ways like egg is no egg to validate, too late to hatch, and all that stuff. So all I'm trying to do is I'm iterating through all my eggs with a while loop, and then I'm just passing them through simple rules. Again, these are all dummy rules, dummy code. So if you go inside that, there's some dummy null check and all that stuff. So all I'm going to try to do is have a egg now, and per egg I'm trying to pass through it, and based on the result, I'm removing them because I should avoid this egg to get processed for subsequent validations, and I'm putting that in this bad failure bucket map, wherein with the index and what is the why is this egg is failure, why this is an invalid egg. Similarly, if I'm doing some throwable rule, which is imagine some kind of DB operation, which kind of throws, I had to try do it in a try catch block, and then imagine if I have to do it on a child validation, I have to uh, I have to really this nesting goes on. So when I have to nest this on a child, so this is how it looks like. I have a try catch, and before that I have to actually to validate the parent, and then go into the extract the children, and then validate the child. So this kind of is not totally scalable at all. It has multiple problems, and the bigger problems are like it's totally complex. And I'm not just saying it subjectively. I'm going to measure complexity with a very popular tool called SonarQube. I'm going to show in a while what complexity for this is. And there's a lot of mutation happening across. Like my particular this list is being mutated. I'm removing things from this. I'm adding things from here, and this is I can't really add more validations in between. But because I don't know what validations I'll be breaking later on, and every time I shuffle the order, I got to update my unit test, which is the worst part. So you might think, what if I just break these things into individual functions? Can that make my life easy? So let's see if that really makes our life easy. So I got to mm, to validation. Yep. So I've broken those operations into different functions. So now they're into whatever I've shown you before are in different functions. That's all right. It looks fine. But what about the orchestrator, wherein it comes here? So this guy, uh, which actually has to call all these validation functions one after the other, and then based on the results it has to either pump it up pump those eggs forward, or else just got to content in the sense break the loop or something. So this guy is still the problem, a same bottleneck, wherein I can't shuffle the order, I can't really place these validations one on the other, or I can't really change this code without, I mean, change the configuration. What I mean is order of validations without updating my unit test or something. This is still not a scalable solution. So what can we do now? Let's see. Let's get back to our presentation. And for now, we got a chaos like this. So imagine this is like an egg, and you're like a developer playing this game. This is how debugging a code like this feels like. You don't know. State is flowing like everywhere. Uh, any function can call any other function, any other validation. This is totally uncontrollable. Hmm. So let's try to treat this with a pattern called chain of responsibility, which is a very popular pattern. Oops. And I'm gonna use FP. But then the question is, FP the best fit? So this is a functional programming talk, of course. What else you expect me to say? Take you till here and say that, oh, sorry, FP is not a best fit, right? Kidding. So FP is a best fit, especially when it comes to chain of responsibility. And validation is one classic case for FP. And from my understanding, I see FP is the best fit wherever you got to do a lot of transformation of data, like we have seen in those small examples, wherein I have to pass that one object across multiple functions, which can be composed, and where the transformation happens in each and every step. And that might be the reason even FP is popular in big data and other transformational heavy domains compared to normal enterprise domains. But then I see software is largely about computation, largely about transforming, grouping things, etc. And FPIC is fit for a lot of use cases, which we kind of are not really taking care or ignoring FP when it's the best fit. So when you see the actual problem is a two-dimensional problem, the moment you think validations or the functions are things too. So we have seen functions as functions, but when you see functions as objects as well, they're entities as well, uh, you get a different perspective of the problem. So you kind of see that this turns into some kind of matrix wherein you can actually mark what validation and which egg passed this validation. So now let's get back to a code and see what I mean by functions are things as well. So this is how it looks when you actually treat your functions as values. I'm going to go inside in depth on what are all this, but for now all you got to understand is now all my functions are now lambdas, and then I'm assigning them to actual variable. That's what I mean by functions as values. So this is what we're going to build now. So we'll have validations, which are our what to do's. The functions I've just shown you, they're all what to do's. And we have two how to do's, which is configuration and orchestration. Configuration is, as I've mentioned, it's like which comes first and which comes next. And orchestration is how they should be run. For example, fail fast or a accumulation. So these three are three different parts. The moment we divide them, the problem really turns so simple and extendable. Let's but first try to do this. We were operating on a mutable list before, which kind of that the reason that anybody can do anything on this list. We had a mutable list in this example. So the moment it's mutable, it's always at risk. You have to really have your debug points and to see what is happening towards what is happening on this list, because everybody has a right to remove or add things to it. And state really gets messy. Again, this is a dummy example, but in our production code, we kind of really do a lot of mutation unnecessarily. We're lucky Kotlin has this mutable prefix to indicate list and mutable list, but in Java at least we don't have that distinction, and uh, mutation is the cause of a lot of silly bugs and hidden bugs which take a lot of time. So we're gonna now operate on an immutable list. I'm gonna show how that. And then another thing that we've got, another problem we got is we have two types of data if you see in our pipeline flowing. So uh, now we got good X, right? But then we got bad X, but I'm not interested in bad X. We're interested in why the eggs are bad. Why, what is the reason for the egg being invalid? So that's like a validation failure, which is a different type. So normally in Java or in Kotlin, there is no list which kind of holds two different types together. So if it's a list of integers, so it can only hold integers, or if it's a list of strings, it can only hold strings. But then now, how can I have a list which has two different data types inside it? So simple solution that we have discussed before, put them in monad boxes. Now that we have learned either can exist in two states, so all I got to do is now, if let us say an egg is bad, I take I convert R either to left state and then let's pump it up so that this particular invalid either monad would be ignored by all the subsequent functions. We'll see that how we're gonna do that. And we got to standardize validations. Now that we're talking this saying this as a framework, I can't kind of really have wild functions in a first approach, imperative approach. Nothing really stops me to write a function with a different signature, or you can write function like anything, like you can wildly write function with different signatures and call any function with any other function. But now the moment we standardize our validations, which is like this, wherein every validation is of type validator. I'm going to go into what a validator is. Uh, it kind of becomes a uniform. Every function is just a different entity, and the framework which kind of runs all these functions doesn't really matter for matter that what kind of function, what the function really has inside. So that's like you're sticking to some rules so that you kind of embed some uniformity into your system. Awesome. So this is how we're going to transform this imperative code or imperative function, that a simple function, again, don't bother about the code. All I'm trying to indicate is this is what we have done before in our imperative implementation. This gets converted to this. But what is this validator? Validator is just a type alias, which is this with the signature. So it's a suspend function, and which kind of takes in a validatable, which is eggs in our case, but this is a totally generic type. And then it expects an output of either which has a failure, or the right state. I don't really care. If it's on right, it's kind of valid for me. So this is the type that we had in the library. We have more types, but then for the sake of this talk, just stick on to the most basic one. So why suspend? Because we have some side effect functions as well. In the sense, we are doing some DB calls as well. So for that reason, we go with this type. And then, so this is how the validations turn into. So now the first validation, simple validation, which is all it is doing is a simple data check, turns into this way. So if I go to validator, I have shown the signature already. So all I got to do is, if this rule has passed, I just have to return something in right. Again, I don't really care whether it's what the result type is, because it's any type. If it's not, I got to return a validation failure. Again, if you see, the signature is totally generic. I don't really know what this like. Okay, I probably have to show you the structure as well. I got to exit the uh, presentation mode. Mm, and okay, so I'm going to share this code base with you. And this code base, I have two folders of packages you can think of, wherein this package has entirely the library code, which is totally generic, which doesn't really know the consumer. So all that you see is generics, which I'm going to explain what is what. And then this particular is something like an app. Imagine you're the consumer of that library Vader, and so you will have certain representation of your validation failure, like rich domain uh, error. So in my case, I have these simple validation failures, and then you can have your own representation. And then I have egg, which is a data class, which is immutable by default, which is lucky for Kotlin guys. And data classes still are not in Java, but you can use Lombok if you need. And then a few dump. Oh, sorry, the font is less, but I'm just trying to explain the the project structure. I don't know how to zoom from here, but it's fine. I'm gonna get into presentation mode soon. Uh, uh, yeah, hope you can see it now. I hope the font is better. Yep, cool, thanks. So they're dummy functions, and yeah, I hope I have explained the project structure. So with that structure in mind, this is how a validator looks like. We have understood what this is, and let's jump on to requirements and how we are solving them. So the first requirement is configure the order of validations. So this is from the consumer. So I have a config class wherein I'm building a chain of all these functions. So we have seen these functions. What are these functions? These are all functions. And by the way, I forgot to mention about this great DSL from Arrow. So if you are a fan of for comprehensions from Scala, you can actually write your code in imperative way without really bothering about flat maps and maps. So I really request you to go and explore this particular DSL from Arrow, which recently got released. And then you can use this nice, cool things which stand for bind, which is flat map. And I'm not going to go in depth, but then uh, as you can see, I don't have any maps or flat maps. So this code really looks readable at the same time. Adheres to functional programming paradigm principles. So Then now that we have seen what these functions are, now that you're clear about these functions, we're going to see how we can actually order these functions so that one function runs after another. So this is how I would kind of build a chain of functions wherein all I need is just a list, an ordered list. I'm going to go inside in depth of how what is this parent, what is this child, etc. But now for configuration, now that my functions are things just like any other objects, I put them in a list, right? And then the second one, cross-share common and nested validations. Now coming back to validations, so I just wrote this dummy validations, and in these validations, imagine there are some parent validations. What I mean is, remember that this structure. So this guy is a parent, the parent JSON object, and then the nested one is referred to as child. So you can have multiple that such dependencies in your depending on your JSON structure. So my dependency is pretty simple. I have a parent, I have multiple children. Like this is simple JSON. I might have more children or more nested children. So it kind of turns into a tree, but then it can even turn more tricky like a graph as such. But then now that you're treating all these functions as values, all you got to do is a topological sort to check what to kind of build a chain of what comes after another. So I have some child validations as well, and in this example I use yoke as a to represent the child, just like my JSON consisted payment method, the egg consists of yoke as a child. So I have these child validations as well. But one tricky part, if you see, is this type is validator and it has egg and validation failure. But here it's yoke and validation failure. Again, the same problem. I can't have these two in one single list, right? If you go back to the config. So I have a list of these guys. So they become a list of the first related. Probably I should even have the type. Yep. Okay, it turned out to be this. But what I mean is, the first one is a list of these functions, and the second one is a list of these functions. But I can't really append this list with this. But then my requirement is I want to run all my child validations after my parent. How can I do that? So I have we have in our library something called a lift DSL, where we are kind of lifting all our child validations to parent context. So what do you mean by lifting? This functional lifting is a popular terminology in functional programming language, but all it is something so simple. So I'm going into this DSL and explaining what I mean by lifting. So lifting is something where I take a function of one type and return a function of another type. So if I just start with a simple example, so imagine this is my parent, and this has a signature of parent and failure, and this is my child, which has child and failure. So I want to convert this child into parent by lifting it. So how do I do this in code? Simple. Uh, I take this function as a parameter, and then I take a mapper which tells me how I can extract the child from the parent. So this is a function which takes in a parent and returns a child, right? So in this particular example, I would just have to say how I can take out payment method out of the big, it might just be a getter of like get payment method. So that would be a mapper. And then these two are wherein imagine if the parent is null or the child is null, what should I return? So now that I'm taking a function, now validator is a function, my return type is another function, which is of parent type. You see, so I'm taking majorly I'm taking this as input and returning this as output. So inside that, what I'm trying to do is very simple. I have a mapper. Now that I have a mapper, I extract child out of the parent, and then based on that, I apply a validation on that particular child. So, but if you see, this is a function. This is a function returning a function. This is nothing gets executed if I call this function. It just returns me another function. So how is this useful? Now, if I go into the config, so if you see the config, now I'm able to happily append this list, this child list with my parent just by calling this, because this guy returns me a list of validations which are of type parent. So which means I kind of in the end my end list of validations or configurations would have a list of this type, list of parent type. But like I said, we have parallel services. So this works if I just have one service. So imagine I have a chicken egg and I have a yolk. Now we have learned how I can kind of lift all the functions which work on yolk into chicken egg. Imagine I have a dino egg, which is analogous to a parallel service. So again, how do I reuse all the yolk related validations with the dino egg? Again, simple. Lift it into the dino egg context. So you don't have to do anything fancy. So you would have a different configuration for your other service. So only the configuration changes. All your validations, which are from the child, can just be reused or appended to a parent, and that's all you got to do. And because this is a config change, this is not actually a code change. If you are familiar with famous dependency injection frameworks like Spring, etc., you would have some XML based config or some Java based or Kotlin based config. So imagine I have to kind of really embed some child validations before and then do some more parent validations. You can do anything. Now that you have a list, you can play around and have your own way of having configuration. So that's the power of having functions as separate values rather than actually trying to orchestrate them, all of them within the code itself. Great. Now that we have seen that, now how can we support fail fast and error accumulation? Like we have two different orchestrations, and depending on your requirement, you might have more kind of orchestrations. So we have seen what are functions. We have seen how we can configure them in an order. Now we got to run them. Simple, right? Now all I got to do is I'm going into something called run a DSL, wherein I would show you how I have two runner DSLs which kind of work in two different ways. So I have validate and fail fast, which actually runs all these validations, which takes in all the validatables. In the sense I said, as we discussed, it's a batch request. So all the validatables would be, imagine there'll be eggs. I'm gonna go into how we can actually run this in our consumer, which is our egg validator. Now I'm just showing you a generic function from the library, and I have all the validators. So what is this? This is from the config. I have a config which have already a list of all the validators which are of parent type. And then I would have a mapper wherein if I have an exception in between, I would use this mapper to convert to a validation failure, and that exception to a validation failure. So it takes in a throwable and returns me a failure T. So I don't know how to deal with your exceptions. Like a DB call might throw an exception. So you as a consumer should let me know that, hey, if there is an exception, please give me this validation failure. And I would return a list of ethers. So if you see, this ethers will have this signature wherein I'll have a bag of valids and invalids. Some may be on the left state wherein I'll have those aliens, wherein I have those failures, and some may be on the right state. So that I take this back, and I'll explain more going forward. Probably I'm jumping ahead. So how is this orchestration being done? How exactly the running being done? So first thing to look at is part drivers, which is an awesome function coming from Arrow again, Arrow coroutine, and this lets you do all the heavy lifting for parallel, doing this orchestration in parallel. What do I mean by parallel? So it's like now that you have all your validation X, and now that all you have, all you got, you can actually run all your validations in fail fast mode on X in parallel. So imagine like this. Imagine you have 4-core system, and this part drivers by default, if I don't specify a thread pool, uses number of threads which are equal to your cores. So at a time, I can really validate 4x if you have a quad-core system, or if you have some hyper-threading, I can validate more than that x, and you're not losing anything on that. But for now, just if it's too confusing for you, just for the sake of this, imagine you have one pipeline of validations through which you're kind of passing your egg, and you get an output whether the egg is valid or not. So this can be done in various ways. So now again, I'll be using something called fold, which is popular again in functional programming paradigm. So all this code might look scary again, a disclaimer. So if you actually go into the code and see what's happening, it's not that scary. But while the talk is going on, I understand it might be difficult to actually see what's going on and understand. But just focus on my words rather than trying to understand what is going on here. So you must be able to connect all the dots once you see the code. So all I'm trying to do is I have validations, I'm folding them, which means I'm aggregating things. It is very popular in functional programming world. And if you're not familiar, you should really go and check it out. And there are various advantages of understanding functional vocabulary, which we're going to talk. So I got a validatable. So by the way, we have seen what the how to run our validation functions. Now that they're all uniform, I just have to fire validation like this simply. So all I got to do is just have the validatable, have the validation, just run the function. That's it, as simple as that. And depending on your needs, you might have other needs. But what I'm trying to highlight is here, the how to do of running this is separate. Now that it is separate, I can also have a different strategy for fail fast as well. This is just another strategy where I'm not using fold, but using a simple map or whatever. Again, you can go into the implementation, and I can now even have error accumulation. So it doesn't matter. I don't have to touch any code within my validations or the config layer. You can have a different orchestration outside of your code, and you can keep switching or enhancing or experimenting with this orchestration without really touching your code or any of your unit tests. And when it comes to error accumulation, I can really run those validations as well as the eggs both in parallel. I have two parallels now. Like I can validate four eggs at a time, and on each egg, I can really run 4 to 5 validations because I have wanted to accumulate errors. I can't do that on failfast because the reason why I have failfast is I want to do cheaper validations first and costlier later. But then in error accumulation, I can really do all of them, and all this is made easier and concise because I'm using part drivers from Arrow library. So that is there. And what else requirements are we left out with? So by the way, like I was talking about fold, there are so many numerous functional programming operations that you can make use of. At least I would say these dozen operations are something you can make use of in a day-to-day coding, which sort of really help in making your code concise. Not just concise, this is like a shared vocabulary, and you don't really have to write all your loops. For example, imagine if I have not used fold here, I would really have to orchestrate all my fail fast this way, like an imperative way. This is just like that agile horse that we have seen initially. I have a lot of for loops, if loops, etc. And no matter how many times I see a for loop like this, I have to really put my mind and understand what's going on there. But the moment I see fold, and if you know about fold, you know what's going on there without really uh, caring about the inside details. And this is same for a lot of operations, and even this fold exists across many languages as well. So if you are reading a different language, you know what is going on if you see a fold there. And same applies to all these other operations. Many such rich operation set which are first hand in Kotlin, which is a great. And if you're using Java, you really have to depend on libraries like var, var. So that's the best part of being a Kotlin developer. And partial failure. So we discussed about the problem of not able to send an aggregated response. And so this is how I'm gonna quickly show how we can get away with that. Wherein uh, just a second. So I have so few unit tests to actually showcase how you can leverage that like a consumer, and you can run these and understand what's going on. So all I'm trying to say is in the end I'll be having a list of validation results, which are a bag of either's, like I said. So they're either left or right state. You can happily pass them to subsequent layers, and the layers doesn't really have to care whether it's valid or invalid. So because we have seen that a function that is applied on a monad that is on left state would totally be ignored. So you as a developer doesn't really have to put extra efforts to kind of filter out what are invalids and what are valids. And that said, what about scalability? We have seen how to run things in parallel. So you can just switch to parallel mode just in case if you need more power. So that said, I'm almost done towards the end. I know I'm over time. So what about complexity? So this is, like I said, there is no subjective way of looking at complexity. It depends on the developer, but there are metrics which doesn't lie. So I used something called SonarQube, and this has I just tried to running using this with the Gradle plugin. So all you got to do is run. I'm just going to pull this up. So if you have Sonar, you just have to have this Sonar. Just you can read out how you can run this. And with the Gradle plugin, I just ran Gradle Sonar Cube, and then I just get these metrics which are pretty impressive. And this is about cognitive complexity. This is better than cyclomatic complexity, which talks about whether the code is human readable or not. And let's see what this complexity metrics talk about. So in the imperative, I have such huge complexity, even though the functions are really less. But then when I go to declarative, and if I see here, the complexity is really low. The reason being a lot of if-else branching is being abstracted by the monad. Monad have underneath has if-else logic if you go into source code, so that you as a developer doesn't really have to care about whether it's a valid or invalid, so that you can write linear code without really worrying about the branching. So, and with that said, FP is not complex. It just it fights complexity, fights cognitive complexity especially. And we got minimum cognitive complexity with same time complexity. This is, of course, popularly known as railway-oriented programming, coined by this guy Scott Plashin, who is popular in the F# world. I really love to, I mean, recommend you guys to go and watch his talk, which where he talks about similar concepts. So it's inspired, and that's an implementation in Kotlin as well. And finally, this is what we got: a linear railway-oriented code from chaotic code. So this is linear. This flows in one direction or the other, left or right. And you can, it's easy to debug, easy to extend, and a lot of XYZ benefits that we have been talking about. And this is where you can find the code and the slide decks. So awesome. That said, I just want to say one thing, conclude with one thing, that you have to use function programming carefully. It's not like a silver bullet everywhere. So at times, imperative style is fine to solve simple problems. Function programming might just kind of make it more complex. So as a developer, if you master both, you would know where to use what. And I would love to hear your feedback. This is my personal email ID. If you have any doubts or any feedback that you can share. And Skadoosh, we kind of won a war over functional programming. Thanks a lot, and I'm open for questions.
Thanks, Gopal. I think we don't have any questions. Nothing on Slido on YouTube. So yeah, thanks so much. It's really nice to talk about complex concepts, but to fight complexity. So in the end, you have to manage complex concept. I saw that you mentioned Alberto Bolano for the article about modern Fantos. Alberto actually had a talk in our first line meetup back in May.
Oh.
So yeah, to everyone who listen your talk, if they want to keep learning the functional programming, especially on Android, go and check Alberto's talk on our page. So thanks so much, Gopal.
Thanks a lot.